Hi and welcome to wrist training. While learning about the brain and thermoregulation. So we will always do one exercise to train wrists, and when I'm going to read from here something about the brain and thermoregulation, and participating in the exercises is at your own risk. Let's start with the first exercise. We're having the arms next to us, we're comfortably standing, the arms in a comfortable position, the hands form to fists, and we're bringing these fists down and up. And we have 3 rules. Rule number 1 is that if any exercise causes pain, we are stopping immediately. Rule number 2 is that we're going only as far as we can go with a little bit of effort and not more. And rule number 3 is that we don't overwork the muscles. We are stopping before they're reaching our physical limit or physical potential or whatever you may call it. So this will be the last time where we're going down and again up. Now to the brain and the thermoregulation. The thermoregulation in humans is controlled by the preoptic area of the hypothalamus. So the thermoregulation in humans is regulated by the preoptic area in the hypothalamus. Little explanation to it. The hypothalamus is one of many regions of the brain. One of these regions is the preoptic area of the hypothalamus region. The preoptic area controls the thermoregulation. So inside of the brain there are different regions, and one of these regions in the brain is the hypothalamus. And inside of the hypothalamus there are different regions. And one of these regions in the hypothalamus is the preoptic area. And this preoptic area controls the thermoregulation in humans. The thermoregulation regulates the temperature of the body so that the body temperature of humans is always at 37 degrees Celsius, whether it's at 26 or 60 degrees Celsius in the outside. The thermoregulation is that which regulates the body temperature for the human body is at 37 degrees Celsius. Even if it's cold or warm on the outside, thermoregulation is the thing doing that the human body temperature is always at 37 degrees Celsius. And that is done by the by the region preoptic area in the hypothalamus, which is inside of our brain. Next exercise, we're having again the hands comfortable next to us, and now we're bringing these hands formed to fists to the inside and to the outside. And let's go for the 3 rules again. Rule number 1, if there's pain, stop. Rule number 2, we're going only as far as we can go with a little bit of effort. Then we're turning around, we're going into the upper direction as far as we can go with a little bit of effort. And rule number 3, we are not using all our potential physical limit. So that this round will be the last one. We're going to the outside and back to the inside. Rats also have a preoptic area. Great to know. So rats are basically like mice. They are animals around this size. They're in different sizes. We have different types of rats, and they also are smaller when they're born and they're growing. And rats are little animals. So rats also have a preoptic area, and so not only humans, but also rats. Neurons in the preoptic area of rats express something called Prostaglandin E Receptor 3. Prostaglandin E Receptor 3. Prostaglandin E Receptor 3. Prostaglandin E Receptor 3. We can dispute for a long time about the pronunciation, but let's say it's Prostaglandin E Receptor 3, and that is expressed in the preoptic area of rats. The next thing, the neurons in rats expressed Prostaglandin E Receptor 3 are helping to regulate its body temperature. So, neurons inside of a preoptic area by rats are expressing Prostaglandin E Receptor 3, and that helps the rat to regulate its body temperature. The next exercise we're having now, flat hands next to us. We're bringing these flat hands to the inside and back to the outside. And last hand to the outside. Back to the inside. So, rats have a preoptic area, probably also in the hypothalamus of the brain of rats, but whatever. So they have a preoptic area, and this preoptic area expresses by neurons Prostaglandin E Receptor 3, and that prostaglandin E receptor 3 helps the rat to control its body temperature. The neurons in the preoptic area of the hypothalamus are giving, through the expression of prostaglandin E receptor 3, continuous signals. So in the prostaglandin in the preoptic area of the hypothalamus are the neurons expressing prostaglandin E receptor 3, and these prostaglandin E receptor 3 are continuous signal given by it. Anything more here? No, it's a continuous signal. So now the pancake flipper. We're having the flat hands next to us and we're lifting the pancake up to the sky and down because we want to flip it. So back to the sky and back to the ground. And after we have done this for another time, we're coming to the part where it's written what is signaled here, or to whom, or something like that, something to the signal. The continuous signals from the preoptic area of the hypothalamus, which are happening through the expression of prostaglandin E receptor 3, are controlling the sympathetic output neurons. They are controlling the sympathetic output neurons. They are sympathetic neurons which are outputted. So the sympathetic output neurons are the signal which is done by the signals prostaglandin E receptor 3, which is expressed by the preoptic area in the hypothalamus of the brain. And that has something to do with the thermoregulation, which is keeping the body temperature at 37 degrees. The next exercise, maybe, the rest will give us more clear sight. Next exercise is, I guess it's the T-Rex in the morning. So the hands out. Bring these hands down. And again up. And up. And last time. Down. And let's look for the clear sight, or if it's still cloudy. The continuous signals from the preoptic area of the hypothalamus, which are happening through the expression of prostaglandin E receptor 3, are controlling the sympathetic output neurons. That was what we had. These sympathetic output neurons are happening in the dorsomedial hypothalamus. Our very sympathetic output neurons are happening in the dorsomedial hypothalamus. Sympathetic output neurons controlled through prostaglandin E receptor 3, which are expressed by the preoptic area of the hypothalamus, are, besides of happening in the dorsomedial hypothalamus, also in the medulla oblongata happening. The medulla oblongata is another region somewhere in the brain. We are making more familiarity with another region of the brain. So somewhere in the brain there's the medulla oblongata, somewhere in the brain is the hypothalamus. The hypothalamus has the region preoptic area, which is doing all this thing here. And there's also the dorsomedial hypothalamus. Was it that? It was for the dorsomedial hypothalamus. So the hypothalamus, I already said that it has multiple regions. It seems to have a preoptic area and some of the dorsomedial hypothalamus. Somehow makes sense. Now the next exercise for the T-Rex in the gym. They're taking a tennis ball in the hand and we are pressing onto the tennis ball. If you don't have a tennis ball, just press the fists together and releasing the tennis ball again. But we are pressing now again onto the tennis ball. We're releasing, but just to press for the last and third time on the tennis ball. Now switching, and we're doing the same again. So we're pressing again onto the tennis ball. We're releasing, but just to pressing on it another time. And releasing again. And it's finally the last time that we are pressing onto the tennis ball. And releasing, and remember this exercise. We're directly going on to the next one. When we hand next to us, we're bringing the hands down with flare fingers. Now we're bringing the hands up and we're making a strong fist. So we're pressing the fist a bit together. We're bringing the hands again down and we are flaring the fingers. And we're bringing the hands again up and we are pressing the fingers together, making a strong fist. Bringing the hands again down and again up. Now we're going on to the cautious big bang. We're placing the fingertips on top of the fingernails of the other hand. And we are opening and we are closing. So that hand presses the whole time on top of the fingernails of that hand. And it's time to switch. and opening against, and the last time opening and closing. If it's warm, the preoptic area of the hypothalamus augments its expressing of Prostaglandin E Receptor 3, which suppresses the sympathetic output neurons in the dorsal-medial hypothalamus and in the medulla oblongata. Suppressing of sympathetic output neurons in the dorsal-medial hypothalamus and the medulla oblongata reduces heat production in the body, and furthermore the dilation of blood vessels, which promotes heat loss. Dilation means they get bigger. It's exactly the other way around if it's cold. The preoptic area expresses more Prostaglandin E Receptor 3 to make the body colder. More Prostaglandin E Receptor 3 suppresses sympathetic output lines, which would make it warmer. The preoptic area expresses less Prostaglandin E Receptor 3 to make the body warmer. Less Prostaglandin E Receptor 3 lets the sympathetic output lines run wide and free, which leads them to make it warmer. Okay, the preoptic area expresses more Prostaglandin E Receptor 3, which if there's more out, they are suppressing the sympathetic output neurons in the dorsal-medial hypothalamus and in the other thing in the medulla oblongata. And if they are suppressed there, the sympathetic output neurons, they are making the heat production lower because they're suppressed. So we're making it lower. And we're also making the blood vessels bigger so that there's more surface area and it's cooled stronger. And if it is too cold, then the preoptic area really expresses less Prostaglandin receptor E suppressor, Prostaglandin E receptor 3, and so they are not suppressed, the sympathetic output neurons, and they can be completely working, and they are producing heat, and they are smattering the blood vessels so that less heat is giving out. They are bringing their fists out and they're turning them to the inside, bringing them up to the outside, bringing them down to the inside, back and down, up, inside, to the outside, out to the inside. Next exercise, the hand next to us, bring the hand down, pressing a bit from the outside of the hand, the inside of the whole body, but all carefully here. Now from the top, and from the bottom. The other hand, the fist down, pressing a little bit against it. Now from the outside, from the top, and from the bottom. And then before the exercise, a little stretching. We're going with the hands over the middle part of the lower arm to relax the extensor digital muscle to the other side. And now we're having pretty much exactly 2 minutes left for the brain and thermoregulation. That the preoptic area of the hypothalamus expresses less Prostaglandin E receptor 3 during fever is even more extreme for the Prostaglandin E2 thing. That fever is regulated through the continuous slowing down of the expressing of Prostaglandin E receptor 3, which is by fever even more slowed down through Prostaglandin E2 was firstly as an idea proposed in 2002. So in 2002 someone said that fever is caused by suppressing the output of Prostaglandin E receptor 3, and which is even increased through Prostaglandin E2. And that causes fever, because if it's suppressed, that the preoptic area really expresses these Prostaglandin E receptor 3, then the sympathetic output neurons are not decreased, and they can make it warm in the human body. Tonic means something like it is continuous. Some vocabulary here. Tonic means it is continuous. Inhibit means that it gets lower and stops or slows down. Disinhibit means it gets stronger, faster, increases. Dilate means it becomes larger or bigger. Augmented means that it has increased or gotten greater. And attenuated means it got smaller, was reduced in its doing. And now the final thing. That by fever, Prostaglandin E receptor 3, with the help of Prostaglandin 2, expressed is suppressed to decrease the sympathetic output neurons in the dorsal-medial hypothalamus and in the medulla oblongata, which increases heat production and dilates the blood vessel size, was as the fundamental principle of body temperature regulation in humans in 2022 proven. I'm going over time a little bit. So it is so that the Prostaglandin E Receptor 3 expressed by the preoptic area of the hypothalamus is expressed when it's warm and suppressed when a fever should come. Because if it's less where it controls less the sympathetic output of the neurons as it gets warmer, something like that. I don't have time. Thank you very much, and until next time.